Guys, very good evening and good morning. Depend, guys, which time zone you guys are right now. Today's, guys, is a very important. I can say the session for AWS because my last two classes I have talked a lot of thing about networking. We have talked about VPC. We have talked about subnet plus SNet and DNet and multiple other things also we have discussed. And what kind of use case can we solve with source netting? That's called SNet. And what kind of use can we can solve with DNetting? That is called destination destination netting. Okay. Today, guys, I'm going to create one complete network infrastructure by using all those concepts and try to show you if you want to create your own uh, uh, private cloud, your own isolated cloud that nobody can enter without your permission, right? And this permission is not always about security, because the first rule in the networking world, right, is if you don't give a connectivity, right, and if you don't give any network wire to your lab, to your house, to your premises, nobody can enter. Okay, so you add the firewall, you don't add the firewall, that is a secondary thing, right? So if there is no network connectivity, nobody can enter. That's called the isolated world. Okay, but yeah, if you give somebody connectivity that they can come from the outside world, then we can start thinking about to whom we have to allow and we have to drop. There the rule and security rules of firewalls or security groups come in play. Okay, so things, if you start building in the terms of infrastructure or network infrastructure structure, that's from the physical connectivity, that's come from the switches, routers, netting, dnetting, s-netting, and all those components. So what we are going to do today, right now, we are going to build an entire network in infrastructure, and almost all the main vocabulary or almost all the main component that we need in the networking world, we are going to construct today. So today's, guys, class is completely practical, very important. If you understand this today's class, so almost any kind of networking thing in AWS cloud, or maybe any other cloud also, like Azure or maybe OpenStack, you can do with the same way and same approach. Okay, but just I want to give a 5 minute summary what we discussed till date, and in this summary I also show you what kind of use case and what kind of demonstration we are going to uh, deal today. So main topic for today, guys, is AWS VPC, and today I am going to show you how to use net gateway, how to use internet gateway, how to use routing table, how to and where we have to use basin host, or what is a public subnet, what is a private subnet, and this kind of vocabulary or setup we are going to do. Or what is DMG, that's called demilitarized zone. Okay, and how we can set up the DMG. So those things we are going to discuss today. Okay, the only prerequisite for today's class is that you guys, if you guys has gone through my last two classes, so that is the prerequisite, and that is the reason, guys. My team has shared, by chance if somebody missed, my team has shared the recorded class of last two classes of this VPC. Okay, so let's start, guys. Very quickly, let me give the summary first. So my plan initially is, I would like to create my own private isolated world in North Virginia. Okay, so first of all, you have to select your region, which region you want to create your own world. And obviously, because you select North Virginia, so in the AWS, if you want to deploy something, you have to use their respective availability zone. Okay, so I'm going to develop or create, or I create a network, or I can say my isolated world is called virtual private cloud VPC on the top of North Virginia. And it means I'm going to use the data center of North Virginia. And this is a VPC service. Okay, so what exactly we would like to develop today? Okay, so guys, before I develop, explain you what exactly we have to develop today, let me explain you the use case. And to explain you the use case, I'm taking example of Google. Okay, so if you guys talk about the Google company infrastructure, in the simplest level, you can think in this way. So they also have one data center. In the one of the data center, they have one computer or one server, and in the one server they are running some web server, or in the web server they may be running some application, maybe search in the search engine application they are running there. Or this computer they are running inside their data center. Due to some kind of reason, they given this computer some IP address, but the IP address whatever they given is the private IP. Okay, and why they give private IP? A lot of reasons there, guys, in networking world. One of the reason, obviously for the Google, that doesn't matter, but it's free, but it's not the important thing. The important thing is because this is private, so it gives you extra facility, and the facility called isolation that I explained you in my last class. And nobody can directly connect to this guy from the outside world till the time these guys want. So inside this data center of the Google, they somebody has given this computer, let's say this IP address 1.2. Okay, so because they have given the private IP address, it means anybody who is there in this data center, and anybody who is connected with their own switches, or maybe who with their own router. Okay, maybe they one laptop connected, maybe they have one more computer connected, mobile connected, so they can connect to these guys. Everybody has their own private IP, and private IP can connect to private IP. I told you in my last class. So everybody has a connectivity, but but yeah. So in this case, I can give one more vocabulary here. It means Google has created their own uh, personal network. Or I can say their own personal LAN. They have multiple systems, computers, devices. They have switches. They have routers. They have. So it means they have created their own private LAN, or I can say they have created their own private lab. But the cloud perspective, normally we use a term called subnet. So they have created their own subnet. But in this subnet, they given everybody a private IP. Nobody has a public IP. Okay, so I can say I can say this subnet is called private subnet. And guys, this is very commonly used term we use in the AWS. So this is called a private subnet. But maybe in the future, these guys decided that I want to expose this server. Guys, whenever I use the term exposed, nowadays exposed means I would like to give this guy or this IP a connectivity from the outside world, or connectivity from the internet world. Right? Or I would like to say, I would like to give this guy that have a connectivity from the world that is different from my private subnet or my different lab. Typically, in this case, let's say internet. So maybe somebody over here on the internet. Okay, let's say we are sitting here. So I'm sitting in my laptop. This is my laptop, and Google decided that anybody from the internet they can connect to my computer. And if this is the requirement, if this is the requirement, it means even though this computer or this server is running in my own data center, having the private IP, but my decision is I want that anybody from the internet, and guys, anybody who come from the internet, they always come with their public IP. I know in my laptop I don't have a public IP, but I have my own router modem that has a public IP. So if I go out to Google, my public IP go. So to make it simple, let's say I'm into the internet. Anybody who is there in the internet, and if you are have an internet connectivity, and if you want to go out, maybe to Facebook or Google, or maybe some personal system, you think you have the public IP, and for the world, they think some public guys or public IP guys is coming to them. Okay, so let's say this Vimal system is want to connect to this guy. The challenge is this guy has a public IP, this has a private IP. Okay, so in this scenario, obviously you guys know, if this is the case, then Google as a company in their data center, they have to add one router, right, at their premises. Okay, and why at the premises? Because this router should have two different network card. One network card will connect to the private world, okay, either with the help of switch or maybe that connected to the server, and one wire, this Google company will connect to their ISP. So Google might also have their own ISP, depend guys which country they are in. Maybe for example if they are India, so maybe they might using BSNL or maybe Airtel or something like this. Maybe. Okay, and because this ISP is the one who connect this router, or using this router, this entire data center is connected to the outside world. And somehow they might be multiple ISP, or we might also have their own ISP. Let's say in my case, I'm using a company called BSNL, and all the ISP in the world connect to each other. Okay, and every ISP has their own clients, own network, own sub network. So maybe that might be reason if all the ISP in the world connect to each other, so we can say it is internet network of network, and every network connect to each other. Okay, so this is not so much important, but this is one small way I will have to explain you. Now, important point over here is if you do so, okay, now the main role come over here. And guys, this concept I already explained you yesterday, sorry, in my last class, right? And I told you whenever any ISP give you a connectivity, right, to the router, and the first router where they give the connectivity, so this is the responsibility of this router, right, to give access to all the internal computers to the outside world. Okay, for example, in your home, it is maybe your modem. So in this case, this router is known as internet gateway, because this would be work as a gateway for you. What is internet gateway, guys? I already explained you in my last class. Okay, and for this, your ISP has to give one public IP to your router. So here we have a public IP. So let's say this ISP of that some company give a public IP to the router or the internet gateway of the Google. Now, if the intention, guys, here is why we give the public IP, the lot of reason, but one of the reason I would like to use the public IP here. So I'll tell my router that you have the public IP. Nobody want to connect you, but at least what I want, Google say what I want this computer. This is my web server. By chance, I have the private IP. So because I have the private IP, nobody from the outside world can connect to me because they have the public IP. So what I want, if you can do one thing, let's say your public IP is 1.2.3.4. So at least do one thing, okay? Inside your router, create one rule that's called net rule. And this rule is, what we will do, we'll announce to everybody in the world that Google has search engine. We won't announce this IP because nobody can come in also. So there's no meaning to tell our IP to the entire world. So we won't tell or expose our IP to the entire world. Okay, what we'll tell to the entire world, if anybody want to connect to this computer, okay, actual IP of this computer is 1.2.3.4. We know this IP belongs to router, but we start exposing. And why are we exposing this? Because they're public. If anybody want to come to from the internet, okay, they can only come to public IP. So if Vimal want to connect to somebody, so Vimal by chance is the part of internet, so Vimal can connect only to the public IP because this is the public IP. But why I'm doing this because my intention is that if Vimal come to this IP, by chance we know this IP is a router IP or internet gateway IP. But in my router, I will create a rule and say if anybody come to this IP, and if this is the destination of the source system, okay, so router do one thing, create a destination rule, denetting rule. Okay, and what you do, if anybody reach here, change this IP, convert this IP to the private IP, and route this packet, forward this packet to this computer. So technically, okay, for the viewer perspective, they are heading to this IP, but internally, for the web server perspective, they feel some guy from the public world come to this server, app server, search engine server, and ask for to their web server and web pages, and they will reply in the same way. They again rewrite the rule the way I explained in my last class. So if you guys see this scenario, this concept I already explained you. There's nothing new for you. But why I'm explaining this concept, guys? But in this concept, you can think this is a very common typical infra or network infrastructure for all any of the company who is providing any web application services, maybe Facebook or maybe Amazon or maybe Google. Okay, but in this scenario, right? And interesting thing is, right, Google say, in my data center I have my own personal web server that has a private IP. Even though they have the private IP, but anybody can come from the outside world and connect to this guy. Okay, and guys, it's not like that this decision is taken by Vimal. Google is the one who have to take the decision. Maybe they might have more computer. Maybe they have one computer called IP3, computer have called IP4. But Google has to decide, or this company has to decide, which computer they want to expose to the internet world. If they want to expose this guy, they go to a router and say, create a denetting rule only for this IP. That's all. Okay. In this case, if you have one computer in your private world having the private IP, it's called private subnet, right? And if you expose this guy without giving the public IP also, I'm not providing the public IP to this guy directly with the help of router. So in this case, this computer is known as, we are providing this computer, or we are exposing. Expose is a very common word nowadays we use a lot. So we expose this computer to the internet. Or we can use one more term, we make this computer and put into my DMZ zone, demilitarized zone. So technically, if you have a private subnet or your own LAN having the private IP of one computer, but somehow, obviously normally with the help of router, by creating the DNet rule, if you give the outside guy a connectivity of that private computer with private IP, then this particular area or that particular computer, we can say now this computer is belongs to my demilitarized zone. And this is a very common setup everywhere we do it, and we have a control, right? So in the future, we feel no, I don't want to give this computer a connectivity outside world. We simply we guys go to router and say, what a rule you have, remove it. That's all. So if somebody come to you, don't forward, don't deny it, okay, and send to me. And just drop there and don't allow there. Okay. Again, guys, it's not about security. Okay. So security means if firewall is the one who dropped the packet. So here, if somebody come to router and say, I would say, I don't know what you're talking about. So I don't know where to take you. I don't know the route also. So we will drop you. We won't respond you. So it's something like this. Okay. So this kind of setup, guys, we are going to do today. Okay. And if you guys want to do this setup, okay, then we have to use a router. Okay. And this router that has a capability of DNetting. So if you go to AWS, right? So in the AWS, if you need a router that has a DNetting capability, that router is known as IG, Internet Gateway. So we are going to use guys IGW, Internet Gateway, as a tool, and this tool is a part of VPC. Okay, this is one thing. So this is, guys, one of the setup we are going to do. Okay, and in this complete discussion, guys, let me create one more diagram to explain the some more 2 or 3 more vocabulary and the concepts. Then let's do one thing. Let's create what I do. No, let's make I explain you first, guys. I'm so sorry. Because I'm very excited to show you this demo, very interesting demo. But let me explain you one more use case. So both the use case, guys, I can directly show you as a demo. But this is the, guys, one concept I already explained you, but this kind of problems we are going to solve today. And one more, guys, concept I just want to explain you. This is called public subnet. Okay. So and guys, this is a very the diagram that I'm going to create right now. This is the very common very common way to implement the services, maybe in your personal data center, or maybe on premises, or maybe on the cloud. So it is something like this, right? So normally what we will do in the cloud, if you talk about, we first create our own private cloud. That you guys know, we can think it is like your own company, the way I explained in my last class, but you can think, you guys know, this is called your own network. So we are going to create our own entire big, office, I can say, but here it is known as VPC or the network. Okay. And in this VPC, what I'm going to do, I'm going to create two different rooms or two different labs. Okay, now guys, please try to understand this concept, which is very interesting concept and very much useful also. So two different labs I am going to create here, and two different rooms, but you guys know this lab and the room here is known as subnet. So this is the subnet, let's say one I am going to create, and this subnet two I am going to create. Now, what is this subnet useful for? Okay, a lot of things is there. I told you guys in my last class, as soon as you create a subnet, behind the scene, AWS has created one switch for us here also, and here also, switch 2 and switch 1. Plus AWS also create one more thing for you, is called DHCP server. Let's say DHCP server 1 and DHCP server 2. So DHCP is connected, and automatically they have a give the connectivity to this switch. Okay, and one more thing they do behind the scene. Okay, in this subnet they create one router somewhere over here. Okay, for this subnet 1, and they also create one more router here, let's say router 2, for this subnet 2, and they also do this kind of connectivity. Okay, and what is this router useful for you? In a minute I'm going to explain you. Okay, so this setup, guys, they will create behind the scene for you. And guys, this router is not the internet gateway. This router has no name. Okay, because they create internally for you for some reason. What is that reason? I will explain you in a minute. Okay, so this setup, guys, they have done for you. Okay, and why they have done for you, right? Because we had created a lab, and we know in this lab we are going to put some computer, and computer we are putting, so we need a networking. And networking, guys, these are three main component and a server and devices in the networking world we always use. Now what happened, guys, as soon as you put a one EC2 instance here, or one operating system here, so as soon as you put the operating system, automatic this operating system will have one network card. This is called ENI, and this network card automatic connect to the switch. Is a by default nature of the AWS. As soon as you start the OS, behind the scene they contribute DHCP, and DHCP is the one who will give the IP to this OS. So let's say they will give IP, but if you want DHCP will give the IP to this OS, so we have to give a DHCP a range, in which range we have to give the IP address. And normally, guys, in the networking world, this range is called network name or network ID or subnet ID. Okay, so we have to tell the DSS server that whenever this OS asks the IP, give the IP between this range. For example, 192.168, let's say 1.0 till 191.1.255. Between this range, give the IP. And guys, anybody who know the networking, we don't tell in this way. Normally we write in this way. I'm going to give my network name, the first IP, and because in this network we have to fetch IP, so I'm giving my net mask. So this is the way we use in the networking world, and tell the DSCP, this is the range I'm allocating to you. Any computer who is start in this OS, give this IP. Okay, but guys, it is not compulsory. In the AWS, we also have a way to manually give the IP also. How we can give, I'll show you. It's pretty simple, nothing special. But normally we always take the IP from the DSCP. Same same here. We also have one more lab or subnet here. So as soon as the one more computer come up in this lab, okay, so we will tell their DCS server here, anybody come in this lab and asking you for the IP address. So I'm giving you a range that's called 2.0 and 2.255. So give the IP between this range. So how normally we tell in the networking world? So we'll say my first IP is my network name 2.0, and total IP is 256, means 244, 24, means 255.255.0. This network range we give to the DSCP. So as soon as this OS come up, or maybe one more OS come up, they give the IP between this range. Okay, so pretty straightforward, nothing very complex here. But in this setup, guys, you know what Amazon has done for you. So in this setup, guys, if this OS, let's say as soon as the OS boot up and DHCP server has give this OS a IP, let's say 192.168.1 point, between this range, let's say they give IP number 10. And when this OS boot up, they give the IP 192.168 because the range is 2 point, let's say 20 they give you. Okay, or maybe some random number they give you, but between this range only. Okay, so guys, now if you see here, this OS is in my lab number 1. This OS is my subnet, or my, I can say, lab number 2. But both the lab is in my network, my VP. So I can say both the lab is in my office building. Okay. So because everything is inside your office, and because your office has your own premises, this black boundary premises, so you can say this is your private world. Nobody can come out and go out without my permission. But both the labs, guys, are belong to my company. So this is my part. So in this case, but is what OS, maybe some OS for my lab number one might want to connect to the lab number two. Okay. But the only challenge here is, okay, both the computers have a IP, okay, but the IP range is different, IP number is different, or their network is different. Or because their network is different, and I told you guys already, if the two computers want to connect to each other, but the IP belongs to different network, we need a router. And guys, that is the one of the reason why Amazon has put one router for here and one router for this guy. So they automatically connect this router behind the scene. And you know, guys, the important thing is this infrastructure that I'm going to show you here. There's no way in the Amazon world to visualize and see this infrastructure, but this is the actual infrastructure they had created for us. Okay, this kind of networking setup they have done for us. Or because this setup is automated done by AWS, that is a reason. That is a reason, right? From the OS one, we can connect to the OS two, or OS two we can connect to OS one. Otherwise, obviously, without the router, how we can connect? And that is the reason, guys. Okay, if you guys know something about networking, I told you in my last class also. Whenever you have the router has a one wire that connect to your internal world, and one network card they connect to outer world. Same here also. And in the router, this network card will have some IP address. And guys, this IP address is always same, or I can say this IP address always belongs to the same network range. So let's say, let's say the IP of this router is 192.168, range is one, or maybe router IP may be one. So guys, this again is done by AWS. So as soon as they launch the OS, AWS has given this network card this IP address. Or guys, if you talk about this router, they also give this router IP of this network range is two, and maybe IP one they give to this router. Okay, and that's one thing, guys. Router is also like a operating system. Even though there's a way you can create your Windows and Linux to work like a router. Router is like a operating system. So whenever this router boot up, this router also want IP. And who give the IP to the router? Again, the DSCP. The DSCP is the one who gave a router to this IP. So Amazon has created this one DSCP server for you, and inside this DSCP, Amazon has told this guy that whenever the router boot up, what are the first available IP you have, give to the router. Okay, and that is the reason, guys. That is the reason in the Amazon world, the first IP is a reserved IP. We don't give this first IP to none of the operating system. So this OS might take the IP2, IP3, IP4, something like this. So this is one IP. Maybe there is a IP1, maybe there is IP254. Whatever the IP, some IP there is out. Okay. So one more thing I just want to tell you guys here is, maybe you know from the networking world, if this is the range of your network, or if this is your subnet ID, subnet network ID. Okay. So in the subnet world or in the networking world, the first IP is reserved. This IP tell you your network name or network ID. Last IP is also reserved. This is called broadcast IP, used for some broadcasting purpose. So in the networking world, not for Amazon, normally in the networking world, two IP is always reserved. But in the AWS world, they reserved five IPs. One for network name, second for broadcast IP, third they reserve for the router of their lab or their subnet. In this case, might be one. Okay, might be one. So the first IP, because zero is reserved for network, the first IP is one. So they reserve for their router. And one more thing, guys, because DSCP is also one kind of server. If their server, DSCP should have also IP address, right? So one more IP, guys, they reserve for the DSCP server. So whatever IP they have, they reserve for the DSCP. And one more IP they have for some purpose. I will explain you in some time. So in the Amazon world, right, five IP they reserve for a different purpose. That is choice of Amazon. Right? You can design your own cloud. You can reserve two IPs. You can reserve 10 IPs. So why is it important to know? Why? Because if you are decided to tell that in your this lab or subnet, or you tell your DSCP that my total IP range is this one, or my network name is this one that I will have to use in this lab. Okay, so in this network range, guys, the maximum IP that is possible is 256. but out of 256 IPs, 5 is reserved. So only 251 is is the usable IP. It means in this lab, maximum OS you can launch or EC2 instance you can launch is 251 only. So if you think, guys, in your lab in EC2 or sorry in AWS, 251 computer is enough for you for your future planning. So that's all. You can go for this. But if you think no, you might need maybe some 500 or 600 computer, then you have to increase the IP range. And how to increase IP range? If you guys know the networking, change the net mask from 24 to 23 or 23 to 22. So I'm not going for that networking discussion, but you can increase your net mask. It will give more IPs in this lab or in this subnet. Same thing here also. So here also they have a total of 250 IP. So out of 256, 5 is reserved for the same purpose for this lab. So only 251 is usable. And that is the reason when you launch the OS, they show you that 251 is usable. I'll show you where they show you in the portal this number. Okay. So guys, this is the this is the internal setup of AWS, and I can give you SOT. Okay, none of the AWS document or any of the blogs you will see this kind of diagram to be created. Nobody talk about what they have internally. How I know there's a different point, but this is the actual. Even though I can prove you by some way, but this is the actual infrastructure internally provided by the AWS. They never show you in the portal or in your system, but that's what they have. But in this example, guys, if you notice one small thing, okay, this lab or this lab, okay, or I can say my entire network VPC is inside the AWS data center, or I can say easy, okay. And you know where we are? We are into the at the internet. So this is my laptop. I am where somewhere in my city in my laptop. Let's say this is me. So I can say I am in the public world, or I can say I'm in internet means public network. Okay, but here, guys, if you see, these guys are using a private IP, and and this computer or this is the one lab they have. So I can say this is a private a subnet. I can say this is also private subnet. Or when I you guys when I use the word private subnet, it means it means all the computer in this lab has a private IP. But this is not the right definition of the private subnet. The right definition of private subnet is, okay, in this lab we don't have any way that will give us a connectivity to the outside world. Okay, it means if somebody outside guys want to send a packet, and they can come inside um, inside my network. Obviously, how they come with this router, and this router connect to this switch connect to this OS. Or why you want somebody from outside world can connect to this OS, because this OS maybe I've configured as a web server. Guys, this is the same example what I explained here. So this is a Google web server, and somebody come from outside world. Okay, so if we want somebody come from outside world, okay, so what we have to do? The most important thing is, again, I'm understand here, most important thing is this is your office. So in your office or in VPC, you have to go to some of your ISP, and ask the ISP give a internet line. Okay, and give the internet to your VPC, to your office. And when they give the internet, they always put one router here. And this router, you guys know, is known as internet gateway. It means it means in your VPC you have to add one internet gateway. And understand one thing, guys, internet gateway has always put in the VPC, right? And how we understood this by this kind of diagram. Okay, so a lot of guys confused with this time. They all try to put the internet gateway on lab 1 or lab 2, subnet 1, subnet 2. No, we have to put the internet gateway at our office premises, means at the VPC. So we have to go to VPC and create the internet gateway there. Okay, this is one thing. So now I can say now my office has an internet line. Okay, and because my office has internet line, now your office will decide which lab you want to give the internet connectivity. So let's say we decide we put one wire from this router, and say we decide lab number 1 we would like to provide the internet connectivity. So I'll take this wire here and attach this wire to the router of the lab one. So if you do so, then I can say my lab one will have a internet connectivity via this internet gateway. Okay, we can say this. Okay, and if you say this, right, now we can say one more thing here. We can show one more thing here. And now all the computer in this lab, all the computer in this lab will go to the internet, or anybody come from the internet, okay, to this lab. Because but always, guys, if you want any kind of connectivity, the first rule is you should have physical connectivity. So in this case, this router is has not physically connected to this router, means to the uh, to the lab number two. There's no connectivity. There's no physical connectivity. So maybe you assign a public IP to this guy, or maybe in this router you create some netting rule or denetting rule for these computers of two IP system two. It won't work because there is no physical connectivity. Okay, but if you talk about this router, we have physical connectivity to the lab number one using the with the help of router one of the lab number one. So in this context, guys, if you attach your internet gateway to subnet, then this subnet, guys, is now no longer known as a private subnet. Then this subnet is known as a public subnet. Okay, because now this subnet is or lab has a direct physical connectivity from the outside world. So, guys, in this example, I have one office, two labs. One lab has a internet connectivity. Second lab we don't have. So second lab, guys, is isolated because without the internet connectivity, without physical line, how somebody can come in and go out. Okay, so I can say lab 2 is a private subnet and lab 1 is a public subnet. And why I want my lab 1 to be public subnet? One of the main reason is, right, is I want one of the OS I have, or it's called OS 1, having IP 1.10. And this is the web server we have configured, or mail server we have configured. I want anybody can see my website from the outside world. It means I want my this OS will go to DMZ zone. Means have a, even though we have a private IP, but somehow with the help of this internet gateway, we are giving this OS outside internet connectivity. Okay, but for this you should have to attach this line to this OS or to this network. Okay, so that's what we want. Okay, so guys, now finally, if you see this, right, in this diagram, all right, in this diagram, there's a lot of interesting use case we can solve if we have this kind of network. Okay, but before this, let me tell you one more small thing to relate the complete diagram. Okay, in this case, your ISP is connected to this router internet gateway. So public IP will be associated here. Public IP. Okay, so we have to go to our internet gateway and say, internet gateway, if somebody come to this public IP, for example, 1.2.3.4 is public IP. So anybody come to this public IP, let's say Vimal is coming from the internet to this public IP. So we would like to create a denetting rule, the way I explained you in the top. Okay. And what we have to do, if anybody come over here to this IP, you have to convert this IP into this private IP and send the packet to this router, and the router is the one who route the thing for you and connect to this guy with the help of switch and other things. Okay, so we have to, guys, create a denetting rule in the top of internet gateway. So internet gateway will give you outside internet connectivity, physical wire plus public IP plus denetted rule. Everything could be connected at the routing. So a lot of technical points here, but if you want to do so in the AWS, so simple, just 2 or 3 setup we have to do, and behind the scene everything has been done by AWS. And guys, that is the reason they are known as cloud, right? They say we hide all the complexity. Just use the way you want to use. You don't have to worry about how to create the big rule. If anybody know routing, they know post routing, pre routing, a lot of rule we have to create. Everything they can taken care by these guys. Okay, but guys, if you have this kind of network, the setup that I have designed here, and same setup, guys, I'm going to design and develop right now. But in this setup, there's one great use case you can solve. Okay, what kind of use case? And very common use case. It is something like this. Normally, what happen? Okay, whenever if you create any website, or normally known as web application. Let's say you create a website in a PHP as a language. Okay, so whenever you create a website, it's called web app. You run your website on the top of some web server. So there's one web server is running, let's say Apache web server, and they host this website. Okay, and let's say this IP is 192.168 1.10. So if anybody from some network want to connect and want to see this website, they come to this IP, maybe direct or with the help of route or DNetting. There's a different point, and they can see the site. But after they see the site, from the site, they maybe e-commerce site. They have to log in, put the login and password. They select something in the cart, or plus they store the information details. Okay, so you know what happened, guys? Normally, uh, those information we don't store in the website or web app or web server. For this, normally, okay, we create one computer. Okay, and that computer is not a database server. Maybe with MySQL or Postgres, depend what database you want to use. So what happened, guys? Somebody or my PHP developer, Python developer write a code, and that's called database connectivity code. So as soon this guy give the login name, password, the information, mobile number, the PHP website retrieve those information, and behind the scene, my code will connect to database and store all the thing in their hard disk in the storage. Okay. So in the future, then they log in, and when they want to update the information, see the information, so they again contact to one of the page of the PHP, but that particular page will go to database, retrieve the information, and send it back and get provided to you. So this is a very typical setup. If you go to Facebook or Gmail, this is a very common setup we have. So technically in this setup, in this setup, guys, now we've tried to understand here is, okay, in this setup, let's say this computer having the IP, any of the IP, let's say 2.20, just for example. Okay, so in this setup, in this setup, there's two different program or two different OS running. This is OS 1 or this EC2 instance OS 2. Okay, in this setup, guys, the most critical computer for you or sensitive part for you is a database server. By chance, somehow somebody hacked this computer, or this system might crash, or some kind of bug come up. Okay, in this system, what we have, just a code, nothing else, just a code. We can again deploy the code, download from GitHub, and again run. We can launch one more server from here, or maybe from the AMI. So this is not the important system for us, and especially in terms of security. But this computer is very critical for us, because all the data, all the info, maybe this is my banking transaction or some accounts or your client details, your login and password, everything is stored in this hard disk. So for the security point of view, this computer is the most critical to look about and to think as a security angle. Okay, especially the, I can say, in overall the database systems or servers. And the best way to secure this guy, right? Even though for security we have SLNX, we have other security, we have antiviruses, we have firewalls, IPS, IDS, tons of things we apply here. Okay, but the best way to secure the system is isolate this guy. Isolate this guy. And if you want to isolate this guy, it means don't expose this guy to internet. And if you don't want to expose, don't connect any internet gateway, any router that will give a direct internet connectivity. Because in the internet, there's a lot of hackers. If you give the direct connectivity, hackers keep on connecting this guy, keep on connecting this guy, and they keep on scanning these guys, exploring some kind of vulnerabilities. Okay. And maybe they might possibly, guys, nothing is perfect. If they find some kind of vulnerabilities here, they hit and they might break it. Okay, they might break it. So if you so don't try to give a direct connectivity to hacker, and best way is don't give the internet connectivity. Internet connectivity. Okay, so only only the things that we have to give, that is that we have to, right, is the web server. So give only web server access to the internet world. So whatever you present in the web server, only those things visible to the hackers or the entire world. But nobody never come to know how web application has been connected, where the database is, what is IP of database. Everything is being hidden, or I can say isolated. So this is the best way, guys, to design this. This may be very complex infrastructure. There might be a lot of things is there, cache servers, other things we might discuss in the future classes. But this is a very typical scenario. Typically, sometimes known as multi-tier architecture. Okay, so we have one computer for different things, second computer for different things, and all the guys work together to create one single application. Okay, single application. So the same design if you want to develop here. Okay, because this is a very common design we always do. So all the computer that you want, we don't want to expose directly to internet to provide them access security, and we don't want, okay, because when, for example, if you go to For example, if you go to Facebook, guys, we always kind of Facebook page, right, or Facebook website. We never bother about, guys, where the Facebook database is. Right now, all the information that you see here, these images, the chat messages, everything come from Facebook database. But nobody asks and nobody interested where they are, right? So you can think this website is running in IP10, and but all the information, whatever they fetch, maybe Facebook is running maybe in the PHP, they fetch all the information over here and present it to you from the database. So where the database running, which database they're running, we are not so much interested as a client perspective. Okay, so that is the reason, guys, for designing our architecture. Okay, we always think, okay, which are the most critical unit, and which one we don't require to give a DAC connectivity to my public guys. So we put all the guys into a world that is isolated, and in our case in our case is called a private subnet. So this OS2 IP20 would be my database server. So I can say I will put my database server in my private subnet, because we don't have a DAC interconnectivity, so nobody can DAC connect to this guy and start scanning and finding the vulnerabilities over here. Okay, but in this case, I have to give a DAC connected to my web server so they can see my website or e-commerce site or chatting site. Okay, so I can say this server we can put into the place where we have a DAC internet connectivity, or maybe somebody helping me to connect to the internet. So in this case, it would be a public subnet. So this OS1 would be my web server. But the most interesting thing is, okay, in this example over here, okay, I want that did what always, guys. I want my PHP side will connect to database. So both have different IP, obviously. Both are different, obviously. But by chance here, they both are in the different room or subnet. But does they have the connectivity? The interesting thing, the answer is yes. That I already told you. So by chance, okay, my lab one computer is by default connected to the laptop. Okay, so by default nature. So because they put the router and router is connectivity. So this computer want to connect to OS number 2, they have a connectivity. So this is by default connectivity. But yeah, if you want in the future, no, you don't want to give connectivity. So by default nature of the AWS, they give the connectivity of lab 1, lab 2, that's belong to same VPC. But if you think no, I don't want OS 1 can connect to OS 2, maybe some reason. So we can put some firewall here. Firewall here. Okay. Or maybe OS has their own firewall. So now there's two different kind of firewall we will discuss in some time that is available in the AWS. So we can put any other firewall, whatever we want. What I mean by this, we will discuss. Okay. So this is different point. So this is the entire internal network setting over here. And there's one more tool here, or one more router available here in the AWS, that's called Net Gateway. So what Net Gateway, guys, I will take in my next discussion. Okay, so first let me build this entire setup, what I drew here. Okay, then after we build, we'll test this setup, then we'll explain you what is Net Gateway. Okay, so now, guys, I believe you guys might understood the proper how the thing work. So let me sorry, 1 minute. So let me, guys, start building this. But before this, you have to tell one more small thing that I already told you. If you think you are one of the subnet one having this network range /24, okay, and other subnet has this network range 2.0/24. So you have to tell your VPC and say what are the rooms you have, labs you have, subnet you have. Somebody has this range, somebody has this range. Okay, and everybody will take the range from you. So you have to go for bigger range. I already explained in my last class. So a bigger range would be 0.0/16. So this is a bigger range. And for bigger network, I can say, right? And from this bigger network, some small network, this lab pick, some small range, this will pick. So it is called subnetting. So from here, they subnet and create a small subnet for you. A subnet. So guys, my last class, I already explained to you in AWS, but I just want to tell you again one more time. Okay. So technically, because while creating VPC, you tell which bigger network you would like to work for. Okay. And after you decide a bigger network, because slash 16 means 2.16 IPs we can put if minus 32 in this network. So you can assign these IP to some IP to lab 1, some IP to lab 2, and something like this. This is called subnetting, and because all the network are in the same length, so I can say this fixed length subnet mask. Okay, so that's what we have discussed in my last class. So let's start from here. So new setup, guys, I will have to do here. I am to be North Virginia. So there's VPC here, VPC here, and so this is a default VPC. We are not interested in this VPC. I'm going to create a new VPC here. So this is called a Linux World VPC, and my bigger network is 191.0.0/16. That's all. That's the only thing right now I'm putting here. So I can, you can say one one Linux World office has been built. Okay, has been built. Mm, click. Now in this office, in this office, okay, um, I'll go for subnet. I create multiple rooms according to my design. Okay, one of the room I will have to create in this office. Which office? Linux World office. Okay, in this office, the room number for, let's say, is Linux World Lab number 1, the subnet one. And I told you guys in my last class, the interesting thing about subnet is whenever you create a subnet, you can decide inside the subnet, whenever you launch the OS, get the switches, router, internet bandwidth, DSCP, RAM, CPU, EC2 services, which data center you want to get those resources. Okay, so I can say for this lab, I will have to get the resources from one, and this is very much useful when I plan for some HA or some kind of disaster recovery. Okay, guys, can you hold for a second, please? Okay, so this one now, interesting thing is already discussed, guys, in my last class. So from this bigger range for this network, I'm going to give the range from here. So for this subnet, I'm going to give the range 1.0/24. That's all. So that's all, guys, nothing new. This part we had already discussed in my last class. Okay, so and create. But now what do you notice here, guys? Because in this subnet, in this subnet, we has given this network range. I told you guys in this network, maximum this IP come up, but because 5 is reserved, so only usable IP that is available for your OS or EC2 instances is 251. And that's what Amazon is also saying to you. So if you click here, they will tell you in this network range or in this subnet, right? The available IP address for the OS is 251. Okay, and why they are reserved, I explain you a little bit why they are reserved here. That's what we have discussed. Okay, now this is one subnet we have created. Let me create one more subnet. Again, I'm creating the same subnet in my same lab. Okay, let's say this is Linux World lab number 2. I'm putting this lab into a different data center. And guys, understand, interesting thing is, even though lab number 1 is in the 1A data center, lab 2 is in 1B data center, and you guys know both the two different data center has some physical distance or maybe 100 miles, even though they have a connectivity. So this connectivity, guys, taken care by Amazon. They have the lines and all the things in place, so you don't have to worry. So any computer in this lab 1 will connect to the lab 2 if they are a part of same VPC, that they are. Okay, and now this guys are using the 2.0 24. Okay, so I'm sharing all the screenshot. If you want to do same practical, you can do this. And guys, one task I'm going to give you right now. Okay, right now what I'm doing, I suggest you also do the same way. Not right now, just right now, just listen to me. Same way with the GUI. And after guys, you comfortable with all those concepts, then try to do the same concept with the command line. So just use the command line, create a VPC, use the command line, AWS command, create submit. So do the same practical with the CLI. And how to use the CLI, and what is the approach to use the CLI, everything I told you guys in my initial classes. So this subnet also has has 251 IPs. They are into some data center. I think I don't know which data 1B I have created here. So this part is created, and by default, guys, both the subnet is private. Why they are private? Because they we don't have a first of all internet gateway in my VPC. And how I know? So for this, if you go to a topic called internet gateway, okay, we had only one internet gateway, and there this internet gateway is already provided by your new account from the AWS. But if you see, guys, this internet gateway is a part of this VPC, VPC E258. And if you see the VPC's name, VPC E252 is a default one that is provided by the Amazon. But our VPC name is VPC 022. Okay, so in our VPC, we don't have any internet gateway. But if you think, guys, in your inside your office, you want to add some of the labs, maybe one or two, or maybe all lab to the internet, right? You have to create one internet gateway. So for this, I'm going to internet gateway, and there's option to create an internet gateway. So guys, the meaning of creating the internet gateway is it is something like this. We are going to ISP, taking one line, putting the router like a modem broadband, and getting some public IP here. So all this connectivity of putting one router can be done by one single click. So one click, that's all. And here they're asking you internet gateway. Let me use the name Linus World Internet Gateway, or let me use IGW Internet Gateway. Okay, that's all. So I'm going to create an internet gateway here. Click. Okay. So this guy's internet gateway is has been created. So it is something like this. It is something like this. You go to market and purchase one device. So your one device has been purchased, and maybe now you have two different offices, office one, office two. Which office you want to attach this device? So right now, guys, this device is not attached. Okay, so which building, which office you want to attach? So in my case, in my case, I would have to attach to my this office called LWVPC. So in my labs we have a connectivity. Okay, so so if you want to attach, so let me start from here again. This is the internet gateway you have. This is detached. No VPC has been attached here. So just click in this internet gateway, and if you go to action over here, there's option to attach the VPC. Which VPC you would like to attach? So here, guys, they show you all the VPC you have. Even though I have two VPCs, but they only present me one name because the first VPC that's called default VPC is already attached to one of the internet gateway. It means in one VPC we can connect only one internet gateway. Okay, and interesting thing you guys might ask me, okay, if you have one internet gateway or one router, and guys, whenever you have one router or one thing, it is always has single point of failure. Okay, that's true. But Amazon say this is my services and this is my managed services. So for you, it look like one internet gateway or one router, but internally, I'm taking care about the high availability. So I am maybe putting a lot of routers here that has a high availability or some kind of cluster setup. So don't worry. So this router is managed by me. Okay, we will taking care about the fail over part. Something fail, I will automatically switch to the different router. So everything will taken care by me. You don't have to worry about it. Just you to tell me which lab over which company or which VPC you want to connect this guy. And now, guys, the good thing about AWS is nowadays when you do something on the graphical, sometime in some of the pages they give you command line also to you. So this is the command they give to you. So the task I have given to you guys can be done very easily. So same thing if you can do from the command line. So this is the command available for this. Okay, and you can change the command for OS level, which OS you want to run the command from. Okay, so internet gateway address. So this is exactly like you purchase the router and put this router in your company and ask the ISP give the internet line. So all this connectivity has been in place just by one click. One click. Now this internet gateway has been attached to your VPC. This part is done. So finally, this part is done. But we just attach the internet gateway or modem or broadband from and can have a connectivity from the outside world. That's called ISP. But I have two labs. I have two labs. Which lab is connected to outside world? So none of the labs we have connected yet. So if you want lab one, lab one will connect to this internet gateway. So it means this kind of wire you want to attach here. Okay. So if you want lab one to have a become a public lab, so how you can do this? Okay. So for this, and before you do so, let me do one small demo here. Let me launch two different operating system, one in lab one and one is lab two. Let me do this thing very quickly. Okay. Then I will come back to this topic again about checking. Sorry, about checking the public and private subnet connectivity. So what I'm doing here, I'm going to launch two operating system. Okay, again using Amazon. Guys, nowadays there's an interesting service they launch. Long we are waiting for. Nowadays they have Max support also. Interesting, right? Mac support also. So you can launch Mac OS also in the top of AWS. That's the interesting thing they launched recently. Okay, well, let's go for Amazon Linux 2. So till here, guys, now here what I'm doing here, I'm launching one OS in my VPC and in the lab number one. Okay, lab number one. Even though you can see here in this lab, we have only 251 IP available. I told you what is meaning of 251 here. Okay, available here. And now interesting thing, I want to tell you one more interesting thing here. The interesting thing is, okay, if you want this OS one having IP 1.10, whatever IP will come up, would be part of DMG, or this system can be connected from the outside world. Okay, so we have to assign public IP, not to this system, to the internet gateway. And we have to create denetting rule and tell my router or internet gateway, if anybody come to this public IP of yours, you have to denet and send this packet to via this router to this OS. This is called denetting. So if you want to create this entire setup, assign public IP to the router and create a denetting rule for this OS, this part, guys, can be done by one single click. You know what that single click is? This one, auto assign public IP. Right now, guys, we are not assigning any public IP. It's called disable. Disable means don't assign public IP to the router. And second thing is, don't create denetting rule for this OS. But as soon as you select enable, enable, just by selecting enable, whatever the internet gateway you have or you will have, okay, they will assign the public IP plus plus they will create denetting rule for your OS. And how they know that they're your OS IP? Because we are on the same page, right? And you click last. Finally, they assign a private IP, and whatever private IP they assign to this OS or to this instance, they will update to your internet gateway. They create a rule for this guy. It's called denetting rule. Guys, we see here it's so simple. So it means if you don't know the concept of denetting also, anybody can do the same things what we are doing here. So guys, the cloud and these guys are trying to make the thing very simple, but for some reason, if you know what is happening behind the scene, it's so much useful if some kind of troubles come up and some kind of customized infrastructure you want to create. Okay, so this is the OS one in lab one. Okay, just for some reason, guys, I'm allowing all traffic, so we don't have to focus much about the firewalls. But firewall, guys, things we have discussed a lot already. and let me assign some private key and launch. Now this OS is launching, guys, on subnet 1. Okay, but here this OS, guys, I asked them to give the public IP. So what are the internet gateway I have? They will give public IP, and the public IP DNetting come to this OS. Okay, so if I go to this OS, so in this case, what you will see, so AWS account portal will show you that this OS has a two IP, one the private IP and one the public IP. So according to the user of AWS, it look like this OS has two public, one IP public and one is private. Okay, but technically, internal perspective, right? This OS has only one IP that is private. Okay, but for this OS in the router, we have assigned the public IP and we did the denetting rule. So this IP is somehow finally useful or is for the OS one. That is the reason, guys, in your portal, if you go to your OS and click on the OS, here they show you two IPs, this one and this one. And if you notice here, this IP come in this range, my network range. So technically, the IP they given to me is not 10. In my case, is 127. But this IP, what are they give me? 54 point something, 155. This IP look like belong to this OS, but it's not. It is the IP associated with the router. So in the last 54 point something something 155. But if somebody come to this IP, because my router denatting rule, they finally landed to this guy. Okay, so I can say if any OS that is a public IP, maybe DAG or maybe via router. Okay, so I can say that OS has an outside connectivity, and if this OS is a part of some subnet, then this subnet can be, not actually can be, known as public. But why I'm saying can be or maybe, I'm going to explain you in 1 minute. Just give me 1 minute, I will explain you. Okay, but let me do one more thing. Let me launch one more OS here, one more instance, and this time, guys, this OS I'm going to launch on the lab 2. Okay, so again, my VPC lab number 2. And now, because our plan lab number 2, we are going to launch OS, maybe database server, very critical. Obviously, I never want anybody can connect to outside world. And the best way is don't give public IP. Plus, don't give physical lines. So now I'm not going, guys, public IP to this OS. I don't want anybody from outside world can connect to this guy. Okay, so I'm not assigning any public IP. Maybe you can directly go for this. I don't want the public IP assigned to this guy. Okay. Next, nothing else. Just give me the OS name. This is OS2 in lab 2. Okay. Firewall, guys, again, for some reason, I'm allowing all. A review, a launch. It's been launched. I don't know, guys. By chance, my speaker is muted. If you guys can tell me, somebody here, at what time my my mic was off. 10 last 15 round mic is off. 1 minute, guys. I'm so sorry for this. I don't know why I forgot to. So 46. I think from last 15 minutes I can see, for last 15-20 minutes my mic is off. Okay, why, guys, 1 minute for this. Uh, any core uh, earth had, right? If you guys can please call me first or message me on WhatsApp, right? At what time, or I can say at what topic I was muted, so I can start from there. Okay, so please, can you, if my earth learner had, if you can very quickly message me in my WhatsApp, right? So it's what topic I was muted. So somebody from mobile number last 501 messaged me. If you can please tell me, at what time, at what time I was muted. If you can tell me. Yeah. So can you tell me what time muted? Just a minute, one, please. 7:30, public private one. Yeah. So I think after I launch two instances, that time I was muted. So I'm so sorry, guys, to waste your time. But I have to again explain you this concept. Finally, you know what I did? What I did? Nothing special actually, but let me explain you. So I launched two instances in lab 1 and lab 2. Okay. And the instance I launched in the lab 1, I provided a public IP. Okay. And that public IP actually associated to the router. Okay. And lab 2, I launched the OS. That OS I haven't give the public IP. So they have only private IPs. So that part I show you here very quickly. Let me show you here. Okay. So this OS, okay, part of lab 2, and because I haven't provided any public IP, without public IP, guys, I can say this OS is a private part of private subnet. And because the part of private subnet, there's no public IP, so there's no meaning anybody can, there's no chance that anybody from the public world can connect to this OS. So I can say this is the isolated OS. But if you go to first one, if you go to first one, okay, the first one, let's go OS the one, and because OS one is a part of my subnet one or lab one, and because I associated a public IP, or because this OS is a public IP, obviously via coming via router with the netting rule, it means anybody who know the public IP of this OS, they can connect. But if I try to connect and try to ping this OS from my laptop, means consider I am into the public world over here, and I am trying to ping to this OS via the public IP, I won't able to connect. I won't able to connect. Okay, why? That's what, guys, I was explaining to you. Okay, because, okay, if you want somebody, so very quickly, guys, let me create this diagram again. This one, what I was explaining you, because that is important concept. So technically, our diagram is something like this. We have one lab. In this lab, we have OS one that is connected to the switch. Switch is connected to the router of their own lab. That's called lab number one or subnet one. And we have one more in routers called internet gateway, that is as a internet connectivity, ISP or P, or internet connectivity. Okay, so till here, everything is done. And what we did, when I launched this OS, I asked this OS to have public IP. But I told you guys, public IP we never give to OS directly. So as soon as you need public IP, technically on the internet gateway, we assign the public IP. And we create a rule that's called denetting rule. And this denetting rule say to the router or IGP, if somebody come to this public IP, in my case, IP is 54 something, 155, means in this IP, okay, you have to send the packet to this OS, to the IP called 192.127, something like this over here. Okay, that's what done. But you know what happened if somebody YSP come to this to this public IP? My router say, "Yeah, this is my IP, but router DNet and router want to send this packet to this OS." But challenge guys over here is right. If one computer, one device want to send a packet to this device, we require network connectivity. We require some kind of physical wire, and this part we haven't done yet. And that is the reason, guys, because that's the reason from the internet I am trying to ping to this OS because some part is missing here. We don't have a actual proper network physical connectivity, so that is the reason we won't able to connect. Okay. Otherwise, everything is in place, but we just want this wire to be connected. Okay. So technically, whenever you guys launch anything in the AWS, let's say you launch one more subnet, let's call lab number 2. They also have a router. And this router wire connectivity is automatically done by AWS because both are the private and belong to your VPC or your company. Okay. But this wire connectivity from the inter gateway to the router is not done by AWS. That we have to done. And why? The AWS say if you connect one wire from internet gateway to this router, and because this router belongs to this lab, it means all the computer in this lab will have actual physical connectivity to the internet. It means you have to decide which lab or which subnet you want to make a public subnet because we don't know. So you want to make this one as public subnet or this one or both, that will be your decision. Accordingly, you can connect the wire like this. So because our decision is to create lab one as a public subnet, so we need to create a wire over here. And how to connect this wire? For this, you have to understand one small rule. The rule is something like this. Okay, what actually I want whenever this OS want to go to internet, maybe Google, maybe Facebook, they create a packet, and this packet go to router. The router has the one because router don't have a DAC internet connectivity. Okay, so this router has to go to this router because this router is the one who has a real physical internet connectivity by their ISP or the other way. Okay, so in this router we have to create a rule and say if anybody inside the lab wanted to go out to the internet, not over here, this connectivity they have already, but wanted to go to the internet. Okay, anywhere in the world, and guys, anywhere in the world is known as by this IP 0.0/0. So this number means any IP in the world. So anybody want to go to internet, okay, we require one router. That router is your home broadband or modem. Here in my case is internet gateway. So we'll tell my router, anybody want to go anywhere in the world, we will use this router. It's called internet gateway. So this rule, guys, we have to create in this router. But technically, we don't have direct access to this router. So as an Amazon perspective, you have to create a rule in my subnet one. But when you create this rule in subnet one, automatically this rule will create it on my router of the subnet. And as soon as this rule created, now I can say my subnet now known as public subnet. Or anybody any OS in my subnet, they can go out. Plus anybody can also come in also. Both the thing will be done. And this guy's rule is normally created in the routing table. So this called routing table. So technically we have to create a routing table that contain any IP in the world you want to go. We require this internet connectivity. And as soon as you create this rule, this physical connectivity done and some kind of internal setup of the router also been updated. Okay, and how we can do this? That's what we are going to do here. But as soon as you do, what you'll see, you can ping to this IP. Okay, but this IP technically we know belongs to internet gateway, but this IP because of the DNet, my internet gateway will connect to the OS one. So if you ping this guy, you will ping here, or if you do access to this guy, you will land it here. Or if you open the website of this guy, you can see the website of this guy. Okay, that's what we've done. And till date, guys, till my last example, we don't have to do this. Why? Because we are keep on using a default VPC, and default VPC is created by Amazon, and they has created all the things for us, so you don't have to worry about it. But here we have to do. Okay, so how we can do this? So we have to again go to internet gateway, and now if you see here, there's a term here called a routing table. Routing table. Okay, and what we have to do, and guys, before I go for routing table, I want to show you one small thing. If I go to subnets, Okay, this is the one of the subnet we have created, and let's say lab one is one of the subnet we have created. Okay, and if I click in the subnet, this is a lab one subnet, or I can say my lab one, this lab one. Sorry guys, this lab one. So if you go to lab one and if you go down, this lab one has one inter router. They never show you, but technically they have, or because they have one router internally, so that router has a one routing table. Okay, and this routing table, guys, is visible here. Okay, so I can say this is the routing table of this router. But normally in AWS, we say this is the routing table of my lab one or subnet one. And what this routing table say, if you see here, this routing table say very clearly, clearly that if somebody use me as a routing table, and who using me, your this subnet, wherever you have subnet, this one, subnet one, where it is, your subnet one. Okay, they can only go to this destination, and this is my local target. Means this is a part of my own VPC. So I'm lab one, lab two, lab three. So anybody who is the part of my VPC, and guys, that is the reason if you see the range here, this range is not the belongs to my lab one or lab two. This is the entire range of my building, my VPC, /16.0.0. So if you have one lab, two lab, three, third subnet, fourth subnet, fifth subnet, all the subnet guys always come in the range of VPC, and this is a range of VPC we have given. So this subnet want to go to any of the lab in my VPC. Okay, we know the route, we know the location, we have a connectivity. But if you guys here in this routing table, we don't have any rule for 0.0.0.0/0 and then go to anywhere, go to internet. Sorry, we don't have this rule. Okay, so technically, this lab is connected to a routing table called RTB066. RTB066. But if you go to second subnet, okay, second subnet, the second subnet or second lab also have a routing table. Again, have same rule. That is the reason, guy, I told you, if one computer want to connect to second OS1 or what OS2, OS2, OS1, they have a connectivity by default because they have this rule. And interestingly, both the OS1 and OS2 is connected to the same routing table. Routing table, guys, is like an information, right? Information. So both have same information, so they can connect to each other. Now, interesting thing is, right? If you want your subnet one can go to internet, so we have to update the routing table with this information, and very simple to update. But if you update this information in this routing table, guys, understand one thing, they both are using same routing table 066, and my subnet one also using the same routing table. See here, maybe they might show you. See here, RTB 066, RTB 066. So if I update any of the routing table, both will update. So it means if I update the routing table, my subnet one can go to internet, but subnet two can also go to internet because both are using same routing table. But that's what I want. I don't want. I want only my subnet one can go to internet, and subnet two won't, because I want this one is private. I want this is a public. Okay. So for this, what you have to do, you have to create a new routing table. Okay. I'm going to create a new routing table. Okay. Create a new routing table. This routing table is already there. That is part of my VPC. Okay. So guys, when you create a VPC, a routing table automatically create for you. But here, and this routing table attached to all the labs or subnet created in this VPC. That is one of the reasons why everybody can connect to each other from one lab to other lab. Okay. And even though if you see this routing table is being has this route, that's why I already show you. Plus this routing table has been associated with subnet association with subnet, both the subnet 1 and 2, 1 and 2. Okay. But if you update anything in this routing table that has internet connectivity, both the subnet update. But I don't want both the subnet will go to internet and somebody come from internet. So for this, I finally we have to create a new routing table. So, when you create a new routing table, you tell which VPC you want to create. So I would like to create in my VPC. Just give the name, um, uh, Linux World new routing table for internet, something like this. Okay, that's all. So there's a new, that's all guys, the routing table created. That's all, nothing special. Okay, and created. So this new routing table created. Let's see a new routing table come up. And if you see here, whenever you create a new routing table, because this routing table I create in my VPC, so by default they automatically create a rule for VPC. It's called local. Means anybody who use this routing table will have this destination connect. Means any of the lab in my office or my VPC, they can connect to each other. Okay, can each other. Okay, but what I want to do in this routing table, I would like to update my routing table. Say I not only want to that lab one lab to connect to each other. Okay. I also want one more thing, that if anybody use this routing table, they can go out also. So in this routing table, I'm going to edit a route. Okay, so I click on edit route. Okay, and I'm going to give one more route here and say anybody who want to go 01010. Okay, means anywhere in the world or come anywhere from the world. Okay, the target means my broadband or modem or my internet gateway is this one. So guys, there's a lot of other devices also who can take you to internet. Okay, we'll see some example, but here the commonly used one is called internet gateway, and this is the one internet gateway we have created in our lab. Come up, that's all. So finally, this has been created, closed. So this routing table did we create in my VPC in my office. Now know that if somebody want to connect one lab to other labs, they can connect. Plus somebody want to go out to the internet, also they can go with the help of internet gateway. And guys, internet gateway is one of the devices. There's some other way also available for solving some other kind of use cases. That's all done. Okay, now let me try. So finally, according to my diagram, the subnet one where OS one is running has this wire connectivity. Somebody want to come in or want to go out, we can go. Okay, it means if now I try to ping, let's see what happened. Now I want to ping, so I'm pinging to the OS one in my subnet one. Again, guys, if you see here, it's not pinging. Why? Because we know we have created new routing table. Okay, but my lab one doesn't know. If you tell the lab one, there's one more new routing table come up, and they are the one who know the route where to go out. So we have to update my subnet also, right? So technically, if you talk about this routing table and we see the subnet association of this routing table is what? Nothing. There's no subnet associated. Okay, or I can say if I go to my subnet one, this subnet guy is still connected to the RDP0066, the old routing table. So what we have to do, we have to go to my this subnet. Subnet is still they're using the old one, and I'll go to routing table of my subnet one. Okay, if you see guys here in my subnet one, they're using the old one. So finally, we have to tell I did the routing table association in my lab one. Yeah, I want lab one will go to outside world. Okay, so here you change your routing table name. That is this one. That's what we created. New RT something. That's all. And guys, as you see change, you can see the two routes come up. This one we can connect to any of the labs in my VPC, and this one we can go to anywhere in the world using this internet gateway. That's is already there in my in my VPC. Okay, and see, that's all. Now, finally, what we achieve, if you see here in the subnet, your subnet lab 1 is associated with a routing table called RTB104. And this 104 say we know how to take you out. But if we talk about subnet 2 or lab 2, they are associated with the routing table called 06, and they say I don't know how to take you out. I know how to do a local connectivity one lab to other labs, but I don't know how to take you out. It means lab 2 is a private subnet and lab 1 is a public. Or because lab 1 is a public, so it means now if I try to connect this guy, see guys, fantastic connectivity we have. I know I have done it pinging, but it's not a small thing, right? Lots of connectivity we have done to achieve this part. Or because we have a connectivity, so I can do SSH also, and I can directly do the SSH from here. So let me connect from here. Okay, let me connect. Last time I showed you guys, it was not connecting. That was error come up. But this time, if I try to connect with the SSH, you will see we have the connectivity. But interesting thing is, guys, if you notice here, I have connected to this public IP. But now we know this public IP belongs to internet gateway, and they do denetting. They change the IP and send back to me. So for the internet guys, for me, for my laptop, we think we are connecting this guy, but finally we landed to IP 192. So if you run here, if you run the ifconfig command, what you'll see, we landed to the private IP of this guy. And the private IP, you guys know, of this one is this one. That's what we have seen here. Okay. And second interesting thing is, okay, very interesting thing, that is that is if you want to connect to this database server or the OS number 2 from my laptop, from my ISP, or sorry, from the internet, there's no way to connect to this OS. Why? Because they're private. Why? Because we don't have a wire connectivity between the internet gateway and the router of this subnet. There's no physical connectivity. Plus, they don't have a public IP. Even though you can give the public IP also of this guy, there's no connectivity because public IP will come afterwards. We first need a physical connectivity. Okay, so we have no connectivity. And guys, if you have no connectivity, so how we can go and configure this guy? Because why we launch this OS to configure database server or something like how we can configure. So guys, here we can again take the help of OS1. So from the outside world, we can first log into OS1, and because OS1 has an internal connectivity to the OS2. OS2. Okay, so it means from the OS1, I landed here, and from the OS1, if I try to go to OS2, okay, so this is OS2, and let me pick the IP. It's called this one. Okay, and try to ping on this IP. Get the OS2 IP. And what I'm trying to prove to you guys that interesting thing is the subnet 1 computer OS1 is connected to OS subnet 2 computer OS2. And interesting thing is both the subnet is belong to different data center also, different AGs also. It's still they have a connectivity. You can see here, they have connected. They can ping. Obviously, if they can ping, you can do SSS to do SSS also. They have your SSS. Right now, I don't have public private key of this guy, but I can upload the private key in this OS with WinSCP, and with the private key, I can do the SSH. And after SSH, you have a local connectivity, and after local connectivity, you can configure the guy the way you want. So here, guys, in this case, in this case, I can use one terminology here. It is something like this. So this is the lab number 1. It has OS1. This is the lab number 2, OS2. And here we have somewhere on the internet. Okay, because this lab is not actually connected to the internet, means private subnet. This lab has a connected to internet, has a public subnet. So if somebody from the public, let's like we as an admin of these guys, okay, want to configure this guy, So what process you have to use? You have to first go and land it to our DMG zone, and from here we can go and log into this guy. We don't have that connectivity. So in this example or scenario, if you want to configure this guy, but you have to take the route like this, right? First you do SSS here, then you do SSS here. So in this case, this OS is known as basin host. Basin host. And normally, guys, we always use a OS that, obviously, if this OS you want to configure as a web server, we don't want to do this because sometimes some kind of security loophole might have come up. So technically, just for managing these guys or configuring these guys, we launch one extra OS like OS one, provide some public IP to this guy. And this OS we only use for one purpose as a basin host, means to manage internal private subnets. Okay, or sometimes also known as jump box, right? So uh, if you search basin host or jump box, same thing. There's no difference. So some country use the word. I think if you go to Australia or New Zealand, this area, so their technical folks normally use the word jump box, and normally India go to US also. Normally we use the word called basin host, but technically they both are the same. So jump box or the basin host are the same thing. Okay, so that's also being created here. Okay, and maybe this OS, maybe you can call for web server, database server, or multi architect. The way I explain you architecture, you can also build. Some more information I want to tell you. Okay, that is, if you talk about this OS, and guys, this OS is actually running in my subnet one, and I told you guys every subnet has their own private router, and every router has their own IP that's connected to these OS. These OS. Okay, and this IP is always belongs to the IP range you have. So if you want to know OS one IP address, so OS one, sorry, Lab one router IP address. So one of the simplest way is in this OS, I can use the command called route -n. And here we can see the IP address. So I am the OS on the lab one. This is my IP, but my router of my lab or my subnet is this one, 1.1. And guys, that is the reason I told you. Okay, the initial and the first IP, I told you the first IP in our lab is reserved. Similarly, they have some DHCP. We have some DHCP command we can find, some more IP reserved for from something might discuss in the future. So that's what, yeah. Even though if you go for this lab, if you log into this term, you can find the IP of this router also, maybe 2.1 would come up. Okay, so but we can enhance this network to do lots of things. So when I go for load balancers, I will enhance something here. But here, guys, till now we haven't discussed about a uh, concept called a common firewall for the entire lab. It's called NACL, and we haven't discussed about a concept called net gateway. So these two concepts, guys, I will explain you tomorrow. Okay, so if you notice here, okay, we have discussed VPC, subnet, routing table, internet gateway. Uh, uh, this concept called net gateway we will discuss tomorrow. Security group, you guys know, it's exactly same thing, firewall. But there's one more firewall here. It's called NACL. We will discuss in my tomorrow classes. Okay, and there's a lot of things is there. Normally, if you go for advanced uh, professor, sorry, I can say specialized AWS training in networking or maybe in security, these concepts discussed there. Maybe even though I try to touch some of the concepts here, might not be part of CSA training, but I'll definitely try to touch other topics also. But main topics we have discussed. When there's some more thing here, we will discuss tomorrow, guys. Okay. So that's all. Lots of things we have discussed. A lot of vocabulary. Practically, I've explained you how the thing work and how the things connected. So, guys, it may take 2 or 3 different shots, right? You have to try. First time you might stuck where to start, how to connect, which component to connect. Just try to practice 2 or 3 times, and after become comfortable, then do the same thing with the command line. So use the AWS command line to do the same things. So that's all, guys, for today. For today, any queries if you have, you can ask me. 1 minute, please. So I can't see any queries because I can see continue message you are muted or voice is not coming. Let me check. With hundreds and messages, thousand messages we have for my mic. Sorry guys, I can't see the new queries. But actually, they come in this. I don't know, in the Zoom meeting, the query come in random order, so I have to scroll up and down. One minute. We we can't create a. 1 minute. Vishal is DMZ. Z means DMZ actually. Okay, so it's demilitarized zone. ZONE is Z means Z. Uh, if only one inter gateway is possible for subnet, then how much? No, per now, I told you, one guys, per VPC, we can create only one internet gateway per VPC. It's not per lab or per subnet. But maybe in one VPC, you have hundreds of subnets, but every subnet will use one internet gateway only. But if you guys might think about the performance or failover or high availability, I mean, say this is my services. I will take care about the high availability and the performance. Okay, so that's how it is. Yes, Abhijit, and the Oracle VirtualBox also, we can also achieve this facility, but only for S netting. D netting facility, your adapter won't help you. You have to go for your modem and the broadband, because normally D netting facility we achieve from uh, intention is we have to go to internet, right? Or my one intention is internet guys will come in. Okay, so that's what. Yes, Avinasan, here, yes, we will talk about EC2 ECS service also. Let's go container services. But if you go to any of service, guys, the concept of VPC we seen, and almost guys all the services use VPC in some form. Even though if you go for ECS or EKS, they use this service a lot. A lot of networking. You know, there's a if you go to Kubernetes or the container, they have a CNI concept, and behind the scene they are using the CNI um, from the VPC. So anybody have done the EKS training for me? That's called Amazon Kubernetes training. Uh, the behind the scene networking they use they use VPC only for the CNI. Balvinda asked me why IPv4 CID is used by AWS for this one. No, Balvinda, this is we decided. 192.168.0/16. We decided. You can change and pick any other one also. Why Ayush asked me why don't we write DNAT rule in the subnet router? First of all, Ayush, we don't have a access to a subnet router. First of all, right? I'm going to say this is the one thing we have given to you. And second thing is we don't have to write, because if you write a subnet denetting rule in the subnet router, so then we have to give a public IP to subnet. And for this, we have to create a subnet router to the internet that we can't manage. That we can't do here, because otherwise they will very complexity come up, right? So I can connect a router one and router two directly to the internet. So we give so one single router that has a internet connectivity. That would be very easy in the terms of management. Alexander, no, VPC service is not chargeable. I can say not all the component charge. Some of the component of the VPC is chargeable, but till now, whatever we did today, it is not chargeable. But yeah, if you're sending the packet in and out, the networking bandwidth charge they will take you. But if you get a VPC subnets, that is not chargeable, it's free of cost. Is Mank, you can set up the passwordless setup between two instances. So if you know SSS key gen command or SS copy ID command, you can use those commands to do a passwordless setup between two instances. Don't worry, Vijay, about your job, right? If you know the concept, if you know the technologies, right? Company need the guys like you. They will hire you. Don't worry. Yes, can we assume multiple IP to one router? Yes, Chatan, we can, and that's what the by default nature of internet gateway. I might take this discussion tomorrow, but yes, in one single internet gateway, you can assign multiple IPs that we want, because maybe I have a requirement 10 system I want to assign with public IP. So all the 10 IP will assign to one single internet gateway. Okay, this is called pool of IPs. Chaitanya, a router and internet gateway. Router and internet gateway is same, but I can say if your router has internet connectivity, and the duty of that router is to write a DNetting rule and help other guys to go and come to the internet. So then this feature of router give a router one more name that's called internet gateway. But technically, internet gateway is actually a router. Is a router. We can use the word a router also, yeah, but to make it the thing very clear, to the world, that this internet gateway means this router, and this router has this responsibility of DNetting and having public IP. So we normally use a word called internet gateway. Yes, others, you have more than more. I think you're asking something. Don't worry, others. DMJ, I think multiple time explain you, but this concept again come right multiple times. You become comfortable. Yes, Lakhan, we will see this example. If you want to connect to VPC and want to connect two computer from two different computer from different VPC, how we can do. So maybe my tomorrow class will give you this explanation. Okay. So will you use Amazon EMR? Yes, Devendra, I believe in my Earth classes, after your Hadoop topic or Spark topic will complete, okay, then I will, in my Earth classes, I will show you how to use Amazon EMR, okay, Elastic Map Reduce Services. So that's all, guys, for today. Of course, Das, I have asked for the Slack channel link. Uh, uh, so Cork, Das, I will again tell my team, or I don't know which group you are in. So if you can ping to your group head, and they will definitely share the link to you. Okay, the Slack channel link. So that's all, guys. I think if you practice this, a lot of query you guys asking might be solved. Otherwise, my future classes will will explain you the concepts. Bye. Take care, guys. See you for today. See you guys tomorrow at same time, 6:30. Bye.